counting sheep, when you're trying to sleep, being fair, when there's something to share, when you know how much money you owe. That's mathematics.
Welcome to our unit on basic arithmetic concepts. Being able to ditch the calculator as much as possible is one of the most important things for math students to do as they advance to more challenging concepts in classes. In this first lesson, we'll review some basic rules for dealing with integers, numbers that can be positive or negative, but don't have a fractional part. Multiplication and division are the easiest, so we'll start with them. The most important thing to remember is how to determine what the sign of your answer is. When you're multiplying two integers together and the signs are the same, then the answer is positive. Two positive numbers multiplied is positive, and two negative numbers multiplied is positive. If the signs are different, however, then the answer is always negative. Let's see how our rules for negatives work with some multiplication problems. First, negative 7 times 8. We know that 7 times 8 is 56, and since we have different signs, our answer will be a negative 56. For 9 times negative 6, we know that 9 times 6 is 54, and the negative with the 6 makes our answer a negative 54. Here we have two negative numbers multiplied, negative 7 times negative 12. 7 times 12 would be 84, and the signs are the same, so we can think of it as though the two negatives combine to make a positive, so the answer is positive 84. Finally, what do we do with three numbers multiplied, as in negative 4 times negative 8 times negative 5? Well, we just multiply the first two first, then we'll multiply the result by the third number. The first two numbers are both negative, so when we multiply negative 4 times negative 8, the two negatives combine to give us a positive 32, which we'll then multiply by the negative 5. For 32 times negative 5, the signs are different, so the answer is negative. Since 32 times 5 would equal 160, 32 times negative 5 is negative 160. Notice from these examples that if we have one negative or three negatives, our answer always ended up negative. However, if we had two negatives, our answer ended up positive. This is evidence of an extension of our rule. If you have any number of values being multiplied or divided together, if there is an odd number of negatives, then the answer will be negative. But if there is an even number of negatives, then the answer will always be positive. We also have some rules that are helpful for doing addition and subtraction when negatives are involved. Here you have to consider two aspects to each problem. First, you need to determine what sign your answer will have. Then you have to determine what to do with the digits. First, if the signs are the same, your answer will always have the same sign. And you'll add the digits. You add the digits because if you have two positive values combined, you're just going to get more positive. If you have two negatives combined, you'll just get more negative. If the signs are different, your answer takes its sign from whichever number is bigger. Now, obviously positive numbers are always greater than negatives, but here we're just looking at their values, ignoring the signs. Once we know which sign to use, we have to find the difference of the numbers, or subtract the digits. We do this because since we have a combination of positive and negative values being combined, some are going to cancel each other out to 0. Let's take a look at a couple of examples of how to use these rules. Our first example is negative 13 minus 8. We need to see these numbers as both being negative, so our answer will also be negative. We can consider them as both negative because subtraction is the same thing as adding the negative. Now that we know the sign of our answer, since the signs are the same, we need to add the digits. 13 plus 8 is 21, so now we know our answer is negative 21. One way we can visualize this is to use discs like these. Each red disc is a negative 1, each blue disc is a positive 1, and when you combine red and blue, you get purple, which represents negative 1 plus 1, which equals 0. Using this, we can see the problem as 13 red discs, or negative 1s, combined with 8 negative 1s. Nothing here cancels out, so we can just count up all the discs and see that we have 21 negative 1s. So our answer is negative 21, like we said. For our next example, negative 12 minus a negative 6, we have to be careful not to jump to conclusions. We see a negative 12 and a negative 6, so we might think we have the same signs here. But notice that we are subtracting the negative 6. This gives us a double negative, which we can combine to get negative 12 plus 6. Now we can see that there are different signs, and 12 is bigger than 6, so our answer will take its sign from the negative 12. Since the signs are different, we also need to subtract the digits. 12 minus 6 is 6, so our final answer is negative 6. Let's illustrate this problem with the discs. After we simplify the double negative, we have 12 negative 1s and 6 positive 1s, or negative 12 plus 6. Here, the 6 positive 1s will cancel out 6 of the negative 1s to 0. Once those are eliminated, we get our final answer, negative 6. Let's do one more. Negative 10 plus 15. Again, we have different signs, and since 15 is bigger than 10, our answer will take its sign from the positive 15. Since the signs are different, we subtract the digits. So 15 minus 10 equals 5, and we know our answer is positive 5. If we illustrate this with the discs, we have 10 negative 1s and 15 positive 1s. The 10 negative 1s will cancel out some of the positive 1s, leaving us with 5 positive 1s. So our answer is positive 5. It is very important that you master how to handle positives and negatives when doing your operations. Make sure to take some time to practice with the activities until you can consistently get these right.